Today on the bench, we have a vintage voltage engineering MO-LUXE 20. I'm going to go into some extensive detail once I get inside, so let's just dive right in. There's quite a few things that need to be addressed, and I'll go over those momentarily. This is based off of a non-reverb Fender Deluxe. It does not have the rectifier tube. A dropping resistor was used in place of the choke. The EQ values are Marshall. The potentiometers are wired from a Marshall circuit. We have an added mid control and presence control, so none of that is part of the original Fender circuit. All in all, good components, CTS pots, SOZO capacitors, F&T capacitors, belt and sockets, switchcraft jacks, and what seems to be 20 gauge PVC hookup wire. We also have a Larmar post-phase inverter master volume, always appreciated. So that's the good. Let's get to some of the bad and the ugly. First up, let's check the fuse. In a Fender Deluxe reverb and a non-reverb, we're going to have a 1 amp slow blow. And this has a 3 amp slow blow. So that's overfused. Going to swap that out before we even turn it on. The next thing is this is your power receptacle. The way it's wired is not up to code. You see this green wire, there's your ground. It's not isolated. It should be grounded near the receptacle itself, and there's even 2 holes already there. So I'm probably just going to use one of those. Then we have the hot that's traveling up here to the switch and then connected directly to the transformer. So it is not fused. The neutral is what this white wire here is going over here to the fuse. So they've got the neutral fuse. So I'm going to fix that, get all that up to code. Next, we have the bias supply. This board is being held on with 1 screw at this point. There are 4 standoffs, and I believe this is the one, either a screw's broken off down in there or the standoff is broke. We'll just have to see. That's a mess. I'm going to have to flip the amp over and show you what's going on the other side, but I'm going to take care of all that. While I'm in here, though, I'm going to also swap out this resistor, which is carbon comp. They don't typically bother me unless they're in the bias supply, in which this is. And what happens is the carbon comp resistors drift in value over time. It means that this resistor will drop a greater voltage over time, which reduces your negative voltage supply. So that means whatever you have over here, as this resistor increases, this voltage decreases, and in this instance becomes more positive. We also want a very stable negative voltage in our bias supply, so we're going to get that swapped out. Before I get started, these are the screw holes for the bias supply. This is the one that's being held in, and if I rotate the board to where you can fit a screw in to that standoff, nothing is lined up on this side. And what it looks like is the builder was drilling a smaller hole there to the left, because if I line it up there, now we have the other standoffs lined up. But this hole is too small to let the correct screw go through that fits into the standoff. The same goes for the small hole on the other side that I just previously pointed out. This, I don't know if it's broken off. That's the screw that was broken off there. So I'm going to fix that and also add some bear traps to the power tubes. All right, here's the top side of the chassis with the new hardware holding the standoffs in for the bias circuit. Went ahead and cemented everything else in just so nothing gets loose. And back to the other side, you can see that all 4 standoffs are securely screwed in. And down here, we now have hot going to fuse, going to switch, then going to the transformer. And the neutral goes straight to the transformer, and the ground is isolated. And all the hardware is cemented in. I've also got to address these heater wires. You see how these are twisted, and these are not. What happens is, benefits from something called common mode noise rejection. In each of these parallel green wires, the current is flowing in opposite directions, and therefore the electromagnetic field that's being produced in each of the wires is 180 degrees out of phase with one another. So if you wrap them like these, then the phases cancel each other out and you reduce your hum. With the heater wires going around the outside of the socket, you're going to want them ran through the middle of the socket or up above. And the reason being, that electromagnetic field I was telling you about, that's what's inducing hum. This is your signal wire coming in, and it is shielded up to this point. You can see where it notches off. So past this point, it's not shielded. So we have no shielding at the end going into the grid here, and one of the heater wires laying directly under the most sensitive signal carrying wire in the amplifier. And so what happens is that 60 hertz hum gets amplified and then gets sent through, and then it gets amplified again and gets sent through. And so before you know it, you've got a lot of hum on your hands. There's definitely some 60 cycle hum being injected into the circuit, but it's difficult to see how much due to the large amount of 120 cycle hum that's also being produced. The reason we have so much 120 cycle hum is due to poor ground layout. If you see here, we have a bus bar across all 4 capacitors, and then right here at this point, that's a wire. That's this black wire that's grounded over here. That all needs to be rerouted. And the same approach that was used here with this bus bar across the back of all the pots. I'm not a fan of this for any reason at all. If you need to swap this pot out, you have to pull every pot out, desolder this point, and then install the new one and solder it all back. It's just a real pain, and it's also very noisy. So there's no benefit to doing it this way. Okay, so the amp is powered on, got the oscilloscope hooked up to the output, and I'm going to roll the master volume up, and you can hear just how much hum there is. And over here we have, we'll say 1.4, so that's going all the way to 1.8. Say we got roughly 3 to 3.5 volts peak to peak at 120 hertz. So that's a significant amount of unnecessary hum.
Many hours later.
Here's the finished product. Got the heaters wrapped and ran over the sockets for the preamps. I've used a shielded cable from the volume pot to this grid also. And you can see where I've added the black wires. We now have 3 ground nodes, one here, and one here. Currently, I have the volume turned all the way up, the bass turned all the way up, and the master volume turned all the way up. All other controls are down there, but let's take a look at the oscilloscope. We're now set to 100 millivolts per division instead of 1 volt per division. So we went from somewhere from about 3 to 3.5 volts peak to peak down to, this is, let me hit stop here. We've got 1, 2, 3, 3.5. 3.5, so 350 millivolts. The hum level is roughly 10 times smaller than what it was before I rerouted everything. Something else I noticed is this is the negative feedback resistor. It's a 100 k ohm resistor, which is more than 100 times larger than what's in a standard black panel deluxe circuit. So let's look at the oscilloscope and see what happens when I insert the resistance for a negative feedback circuit in a deluxe. So this is 10 times less than what it was. I'm inserting the resistor now. And now we've dropped to 50 millivolts. So we went from somewhere between 3 to 3.5 volts down to 50 millivolts. The amount of hum that is here now is somewhere between 60 to 70 times less than what was there initially. So I think that's a good stopping point for this video. I've addressed quite a bit and made some significant improvements. For anyone wanting more information about what it was that I did, if you're an amp tech, amp designer, amp builder, or just in need of some light reading, you can pick yourself up a copy of Merlin Blend Co.'s Designing Power Supplies for Tube Amplifiers. You can also check out their website, valvewizard.co.uk, for some free information. You can also purchase their books from that website. I am not affiliated with Merlin Blend Co. or their product, but I do highly recommend it being part of any quality amp tech's library. And one last thing I'm super excited about is this new little bitty wireless Audigo microphone. And so from now on out, you're not going to have to hear my amps and pedal demos over a cell phone microphone, or hopefully, we'll see. Fingers crossed. I've got high hopes for this. So if you made it this far, thanks for watching. Like and subscribe, and comment reduced noise floor in the comments below. Take care.